More than 2,000 years ago, a scholar in Egypt measured the size of the entire planet without ever leaving the ground. His only instruments were a stick, its shadow, and a single day of the year, and he came startlingly close. By his time, educated Greeks already knew the Earth was a sphere. Aristotle had seen its round shadow fall across the moon in an eclipse and watched new stars climb into view as travelers journeyed south. What no one knew was how big the sphere was. Its size was pure guesswork, a number no one had ever measured. Eratosthenes, chief librarian at Alexandria, asked a daring question. Could you measure the whole world from a single stretch of it without ever leaving the ground? His insight was that a shadow holds the answer. On a flat Earth, every noon shadow would fall at the same angle. Because the Earth curves, that angle shifts from place to place, and the shift is a measure of the curve itself. He started with a fact about a town far to the south, Syene, which sits close to the Tropic of Cancer. There, at noon on the longest day of the year, the sun climbs almost to the very top of the sky. Upright poles cast almost no shadow. It was even said the noon sun lit the bottom of the wells. At that same moment, well to the north in Alexandria, an upright pole did cast a shadow. Eratosthenes measured it. The shadow leaned by 1/50th of a full circle, what we would call about 7 degrees today. Same sun, same instant, 2 cities, yet one cast a shadow and the other almost none. Why should that shadow mean anything? Because the sun is so far away that its rays reach the Earth effectively parallel. Extend the 2 upright poles down into the ground, and they meet at the center of the Earth. The angle between them there, the slice of the planet that separates the 2 cities, is exactly the angle of the Alexandrian shadow, a 50th of a circle. A shadow at your feet had measured the curve of the world. So the arc from Syene to Alexandria is 1/50th of the way around the whole Earth. Whatever that stretch of ground measured, the entire planet was simply 50 times as far. And that stretch of ground was a known figure of the day, about 5,000 stadia between Syene and Alexandria. 50 times 5,000, 250,000 stadia. The whole circumference of the Earth, reckoned from a shadow. Some ancient accounts put it at 252,000. How close was he? That turns on the length of his stadion, an ancient unit we can no longer pin down. By the shortest likely value, he was off by a percent or two. By others, more like 10. But the point stands. More than 2,000 years ago, with no instrument but a shadow, geometry alone had the size of the whole planet. Its beauty is leverage. A cosmic quantity, the size of the world, pulled down into a schoolroom exercise in proportions. No fleet, no survey of the globe, no instrument, but a stick and the sun. Only one bold assumption, that the light arrives parallel, and the nerve to trust a chain of reasoning enough to stake a number on it. 2,000 years before anyone could look down and see the Earth whole, a shadow had already measured it. Beautiful experiments.